So let's look at an example where we execute a multiplexer using Dataflow, but the Dataflow is going to be housed inside of some procedural specification. So the first thing that I always like to do is think about what variables are going to get modified by my procedural specification. And this one's actually pretty simple because we have three inputs, and so obviously we're not going to be modifying those. Those are going to be modifying our output. And I almost kind of gave it away right there, right? Our output is going to get modified by our procedural statement, right? Or we just labeled it, we call that out. So that means that we need to put a reg here. So any variable that is changed, so it could be an output or a wire, would never be an input. An output or a wire that is changed by a procedural statement has to have this keyword in here, reg. So now we've got that taken care of. Let's tab over. Oops, I wanted that to be 3 tabs. Whatever. All right, and now we're going to have our always at statement. So always at, and then anything in the sensitivity list, that's just a list of things that when it changes, we run all the code underneath. That's what it means. So what could change that would make us want to change our output? Well, really, any of the inputs, x0, x1, or c. If any of those change, we're probably going to want to change our output. Especially given our data flow expression, it depends on all three of these variables. So if any of them change, we need to recalculate our output. So I'm going to do x0, x1, and c. And then I'm going to block myself in here with some begin and end statements. So we've got begin and end, and I'm going to work inside of this. Now, what I'm going to do is I'm going to say out equals, let's just put the full statement in there first. So out equals x0 and I'm going to put in parentheses here not c. This is just a function that we found in the previous lecture. And I screwed up in the previous video. I did a plus here, and that is actually addition. What I should have did is this bar here, right? This is our OR symbol. And then we have x1 ANDed with c. And these are lowercase, my bad. Lowercase. And then we can end it with a semicolon. So this is one line, and to be honest, it doesn't actually add anything special by putting in this always at statement. The way this executes, right, is anytime this changes, it could be a 1 to a 0 or a 0 to 1 for all three of these. When it changes, it says, oh, all right, now we need to run everything in between this begin and end statement. So in this case, it would just be this single line. So, and also real quick note that we don't have an assign statement. We only use assign statements outside of our always at blocks. Oops. But we could also split this up into 2 steps if you want to. Say we have a really long function here. Something I could do to split this up is I could take this term away. And then I can say out equals out, so itself, ORed, with the second term. So remember, in the previous specifications we saw, everything kind of all happened at once. And so physically it doesn't all happen at once, but you can kind of assume that everything is kind of happening at the same time. Whereas this, it goes in as a more conventional programming language that you might be used to, where it calculates this step and then it calculates this step. So, oops, we need a semicolon there. So that's something to kind of be conscious of, is where one line, it might only take one quote-unquote clock cycle, but now two, you've got 2 clock cycles worth of computation. So it's just going to slow things down a little bit, but sometimes you actually need to do that. Sometimes you need to split things up into multiple steps like this, and that's what procedural is really there for.